when your denominator is a polynomial, or rather quadratic polynomial, okay, there are a few things that you need to recall. The first one being partial fraction. So partial fraction is actually given in your MF27. Okay, so these are the three cases of partial fraction that you have to know. And then you have to combine with all the concepts that you have learned before, which includes the integral of f prime x, fx to the power of n, and this is equals to fx to the power of n plus 1 over n plus 1 plus c. You have to recall the integral of f prime x over fx, which is equals to ln of fx. If you are not very sure in all these cases, first please make sure you are good, okay, and recap by looking at the previous videos. And you need to remember that if I want to integrate anything with a square root 1 minus x squared, that is going to be inverse sine, and these two are actually given in your formula sheet. Anything that is 1 over a squared plus x squared is going to be equals to inverse tangent, okay? Now there are also two others that you can use, which is in your MF. That would be previously when I talk about this, this is differentiation. Let me see where's the integration. Sorry, this is the integral part, where you see if you can make it to x squared minus a squared, it's going to be ln. A squared minus x squared is also going to be ln. But I'm going to talk about this later on, because in order to use this, there are easier ways, okay, to do that, and that is where the partial fraction, okay, comes in. So there are three cases of partial fraction. Case 1, if it's linear factor. Case 2, repeated linear. And case 3, quadratic factor. Now, whenever you get the quadratic as a denominator, okay, there is a flow chart that I want you to know first. So if you have a quadratic denominator, okay, check whether is the numerator algebraic also. If the numerator is also algebraic, and then the power of the numerator is greater than equals of the power of the denominator, so this is numerator, denominator, first you must do complete square. Sorry, not complete square. First you must do long division to split it. Okay? After you do long division, so remember long division is called quotient plus divisor over the, quotient plus remainder over the divisor. Then we can apply next. Now, if it is not a quadratic denominator, then you see whether the denominator can be factorized or not. If it can be factorized, good, then you do partial fraction. Later I'll give a nicer flowchart for you, okay? Partial fraction. If cannot, so this is yes, no, then you complete the square, okay? And then we will see how each cases go, okay? So here are 4 general cases, okay, that I'm going to talk about. So first is, look at the denominator. Can you factorize the denominator? Yes, it's the same as 1 over, so this will be x minus 5, x plus 2. So if you can factorize the denominator, good. I use partial fraction to split it up. Something over x plus 2 dx. Okay, so I'm going to do the partial fraction at the side over here. 1 over x minus 5, x plus 2 is equals to a over x minus 5 plus b over x plus 2. If you understood how to use cover-up rule very simple. Look at the denominator. So which means I sub x equals to 5 on the left-hand side. And as well as I disregard him because I cannot use 5. Yeah. Then very simple. A is just going to get me 1 over 7. Okay. Same thing. I use cover-up rule for b. I sub x equals to negative 2 on the left-hand side. So now in this case, instead of covering x minus 5, I cover this one. Okay, I'm going to put it inside. I'm going to get b equals to negative 1 over 7. This will only work if it's repeated, it's linear. Okay, like this is easy cases to do. If not, you can just say that, the 1 numerator is equals to, I make common denominator. Then I talk about the numerator. I sub in the x5 is 5 and x is 2, I'll still get the answer. Okay, so I'm going to get 1 over 7 and negative 1 over 7. So this is 1 over 7, and this will be negative 1 over 7. Okay, I can actually take out the 1 over 7, the integral of 1 over x minus 5 minus 1 over x plus 2. And at this point of time, if you don't know that if I integrate 1 over x minus 5 is equals to ln modulus x minus 5 minus ln modulus x plus 2. Okay, that means your integration is not strong enough. Okay, you have to practice more. Okay, you have to go back to either look at your summary sheet. Okay, yeah, be good at this. So number one, if you can make it to become if you can factorize the denominator, then use partial fraction. Okay, so for B, I'm just going to clean this and say this is B. For this, okay, can you factorize or not? So you realize that I cannot factorize. If I cannot factorize, I got to complete the square. First, take out the 2 of the denominator, and this will be x squared minus 2x plus 3 over 2 dx. So this is half integral. So now I'm going to complete the square inside, x minus 2x plus 1 square minus 1 square plus 3 over 2. So this is half the integral of 1 over x minus 1 square minus 1 minus 2 over 2 plus 1, so that will be plus half. Okay, so you must make it in the form of x squared plus a squared. This is half the integral of 1 over x minus 1 square plus 1 over root 2 square, okay, dx. Now you look at your formula sheet. Okay, I'm just going to bring my formula sheet down here. Okay, or rather I'm just going to say over here, the formula sheet says that if you integrate x squared plus a squared, this is equals to 1 over a inverse tangent x over a plus c. Let me just check it whether I wrote it down correctly or not. I can't be sure whether is it 1 over a or 1 over 2a. It is, yeah, 1 over a. Okay, 1 over 2a is for ln. And so all you need to do is to apply. Who is my x? This is my x. This is my a. I'm going to get half. Take a big bracket. 1 over root 2. That will be root 2. Inverse tangent x minus 1 over root 2, so that will be a root 2 over here. Okay, then close plus c. Okay, so must know what is your a and everything. So first choice, can factorize denominator, make to partial fraction. Cannot factorize denominator, don't make to partial fraction, then make to complete the square. Okay. So for C and D, okay, which is more complicated, I'm just going to put it on the other side. For C, you can see that the power of the numerator is greater than the power of the denominator. So for C, the first thing that comes to your mind is you have to do a long division. Numerator is inside, 18x minus 21. Denominator is on the outside. That's the divisor as well. So I will have an x here because this multiplied by this will give me x cubed minus 3x squared minus 10x. Be careful, put a negative and there's a bracket over here. Draw a line. You're going to get 3x squared minus 18 plus 10 minus 8x minus 21. So you have a plus 3. I will get 3x squared minus 9x minus 30. Put a minus and a bracket over here. I'm just going to get negative x plus 9. Okay, so for C is a lot more complicated because the integral of x cubed minus 18x minus 21 over x squared minus 3x minus 10 is going to be equals to quotient x plus 3 plus remainder negative x plus 9 over divisor. So now you look at the divisor. Okay, can the divisor be split into a partial? The divisor be factorized? Yes, it can. Minus 5, okay, x plus 2. Okay, so good thing is now we can make this into a partial fraction. So the integral sign is going to be here from dx. First, I can integrate x. I'm going to get x squared over 2. Integrate 3, I'm going to get 3x. Okay, plus the integral of, So for this guy, we got to do partial fraction by saying that, okay, minus x plus 9 over x minus 5, x plus 2 is equals to a over x minus 5 plus b over x plus 2. You can use the cover-up method as well, okay, sub x equals to 5 into my left-hand side, I'm going to get minus 5 plus 9 over 5 plus 2. So this is my a, okay, that will be equals to 4 over 7. Sub x equals to negative 2 on my left side, I'll get 2 plus 9 over minus 2 minus 5. Okay, that would be negative 1. So that's my b, that would be equals to this. So a, let me just check whether I'm correct or not. Yeah, correct. Is 4 over 7 x minus 5, okay, minus 1 over x plus 2. Then in this case, these are just easy integration. Plus 4 over 7 put on the outside. This will be ln x minus 5 because the integral of 1 over x minus 5 is equals to ln x minus 5. Remember to put your modulus. Okay, so this should be a modulus. This should be a modulus minus ln modulus x plus 2 plus c. Okay, and that's it already. So the more complicated thing is if it is a quadratic at the top and the power is greater or equals to the power below, then you have to do long division first, then do partial fraction if the denominator can be factorized. Okay, now what happens if the denominator cannot be factorized? So let me give one example ahead of what I'm going to do for d. That would be something like this. Okay, so first I check the numerator of the power of the numerator is 1, the power of the denominator is 2, so no need to do long division. Second, can my denominator be factorized? My denominator cannot be factorized. So if my denominator cannot be factorized, okay, before you go and do complete the square, especially when the top is this, think of f prime x over fx first. So if this is my fx is equals to this, f prime x is equals to 2x plus 2. Okay, so I need a 2x plus 2 as my numerator first. Before we settle the 2, let's look at 2x. Okay, I want a 2x to be my numerator. So this is the integral of, I put a half on over here, I have 2x. But when I multiply the numerator by 2, it will become 2x plus 4 over x squared plus 2x plus 5 dx. So I need to split this. Why? Because I need to force a 2x plus 2 as one of my fractions. Later I'll explain why. Plus 5 dx. So to make it equal, you need to have a plus 2 because 2 plus 2 is going to be equals to 4. That these 2 and these 2 will make up to be equals to 4. X squared plus 2x plus 5 dx. Okay, so now the first step of doing this is so that I can force a f prime x over fx out. So when I integrate f prime x over fx, do you know your integration technique well enough? This is ln modulus fx. The first integral of the fraction is just going to become ln modulus x squared plus 2x plus 5. That's it, because it's f prime x over fx. The second one is more complicated. Take a 2 on the outside, integrate 1 over, now I know that this guy cannot be factorized. So what I have to do? Complete the square. X squared plus 2x plus 1 squared minus 1 squared plus 5 dx. Continue to write whatever you have done for the left side one. Okay, plus 2 integral, this will become x plus 1 square plus 4. 4 is 2 square. And if you look at your formula, you have to identify that this, the integral of that fraction over there, or the one that is behind, of x squared plus a squared is inverse tangent x plus 1 over 2 plus c. Okay, so this involves splitting, and when you need to split, there are two integration techniques that must come to your mind first. Either this or the integral of f prime x, okay, fx to the power of n. And when we'll need to use this guy instead, okay, I'm just going to talk about it over here in the next example. Okay, something like this. If you have the integral of something that is going to be more complicated, maybe we have x over square root of 4 minus x square. Okay, maybe, yeah, I'll put the 2 here for convenience sake. Okay, dx. Yeah, so first thing that comes to your mind is the numerator on top is algebraic, right or not? Okay, then you let your fx equals to the inside 4 minus 2x minus x square. F prime x is equals to minus 2 minus 2x. So I need this as my numerator, okay, which is going to be very tedious. First, settle the x. So I have a negative half here. I need to have a minus 2x on top. Square root, look at the inside. Doesn't matter the inside can factorize now, because when it's square root, right, you have to think of inverse sign. Okay, yeah. So to make it, I want to have a minus 2 because I want to have f prime x at the top. So I will need to have a minus 2 as well as a plus 2. This is called a zero sum to make the two things equal. Why do I have to do that? It's so that I can force the f prime x to be on top. Okay, then I will have a plus 2 integral of 2 over square root 4 minus 2x minus x square dx over here. So actually the half encompasses the whole thing. I think I may have made a mistake in the final one, because the half should actually take care of the whole thing. Yeah, here, okay, so there will not, the final answer will not have a 2 over here. Okay, but doesn't matter. Okay, so when I come back to here, the first guy, minus half. Okay, now because this is a square root, right, I cannot use f prime x over fx. I have to bring it up. This is minus 2x minus 2, as well as this is 4 minus 2x minus x square to the power of negative half dx. So I think this is my fx, right? Is this my f prime x? Yes, this is my f prime x. In fact, to help you better, always write this is fx to the power of what first? Okay, so I'm just going to settle this guy. This guy is just going to be equals to negative half, put on the outside, big bracket. Oh, integral of f prime x fx to the power of n is 4 minus 2x minus x square. Raise the power by 1, by half. Divide by the new power, half. Okay, so this you have settled already. Okay, I multiply the negative half to the 2 as well. So this will become like a minus. The integral of 1 over square root 4 minus 2x minus x square dx. So this is called splitting. The first part will always be either f prime x over fx or fx to the power of n. Okay. The second part, I'm just going to focus on the second part. The second part, whatever is inside the square root, you got to complete the square. So I got to complete the square, take out a negative, I will have x square plus 2x minus 4 dx minus the integral 1 over square root negative x square plus 2x plus 1 square minus 1 square minus 4. Okay, so this is just equals to 1 over square root, this is 5, put it as root 5 square minus x plus 1 square, a completed square. This is a completed square. Okay, so what integral of 1 over square root, you must know is sine inverse. Then look at your formula sheet. Oh, they say that if you integrate square root a square minus x square dx, this is just equals to inverse sine x over a plus c. Just apply this inside. This is equals, so I'm just going to focus on this part. This guy is equals to, the negative is still on the outside, integrate this, I will get inverse sine x plus 1 over square root 5, okay, plus c. So this is just for this side. Whatever you have done for the first, this part, just make it nice and then write down the answer over here. Okay, so if you want to know how to do splitting of the algebraic fraction, okay, first thing, see the quadratic, the power on top is greater than the power below or not, or equal, also have to do long division. After you do long division, then you have to look at the fraction again. Is it an algebraic fraction on top? If it's an algebraic fraction on top, think of split it to become f prime x over fx, or f prime x, fx to the power of n. Okay, and then the other guy, as long as it's numeric on top, it will be sine inverse or tangent inverse.